Assalamualaikum and a very good morning lah. Okay, so even though you watch my video afternoon ke evening ke, but our class is morning, right? 11 a.m. So good morning. Okay, alright. So we already enter week 2. Okay, so hope that the what we learn or what we learn for the last week punya topics you can understand well lah, okay? Because of now we want to enter with the new chapter. It's not a new chapter, it's still in chapter 1. It's about it's still under matrices chapter, but it's maybe it's a new for you, or maybe some of you already learn in diplomas, okay? So this is about the solution of a linear system. Okay, so I will brief you according to the slide first. Okay, so the solution of the linear system. So I hope that we can go through together the slides. Okay, alright. So first of all, actually, for the even if you can see my slides for the previous chapter or the previous topic, they have a lesson outcome. Okay, so I forgot to brief you about the lesson outcome. So actually, for each topics that you learn in every week, they have a lesson outcome that you should get. So upon the completion of this lesson, you should be able to. So here there are 4 points. Okay, the first one is you will able know how to reduce a matrices into row echelon form using a row reduction method. And then for the second one is you should know how to solve the linear system by using Gauss elimination. And for the number 3, actually the short sentence is actually you know how to solve the linear system by using LU decomposition. And the last one is you know how to solve the linear system by using Gauss-Seidel. So basically they have 4 points here. So and if you can see that they have 3 methods. Okay, so they have 3 methods. So I highlight again, you will learn 3 methods to solve the solution of a linear system. Okay, alright. So maybe if you can refer to point number 1 here, maybe some of you will ask or wondering what is a row echelon form. Okay, what is a row reduction method? Okay, don't worry yet. Okay, we will go through one by one later on. Okay, so but before that, okay, this is the introduction of the linear system. Maybe some of you are wondering why we learn the linear system, where we can apply this. Okay, basically a linear equation. Okay, linear equation is that you learn actually. Okay, so linear system is a set of a linear equation. Linear system is a set of a linear equations. Maksudnya you maybe ada 3 ataupun 4 linear equation. So and then we combine it, so it become systems. Okay, so system of linear equation is a collection of a linear equations. Okay, that involve a set of variables. So they have a set of variable lah. Okay, set of variable means they have more than one variable that involve. Okay, so it's represent mostly in the system in engineering, physics, chemistry, and computer science, and also economics, because it's play with the variable. So variable can be any things. You already learn in science, right? So variable is a formula. They have independent variable, they have a dependent variable, and so on. Okay, alright. So here is an example. So example here. So this is the first one. Okay, the thing that the equation that I highlight here is the first equation. So you have one equation here. It's a linear equation. This one is the second linear equation, and this is the third linear equation. Okay, so then we combine this, we call it as a linear system. Okay, alright. So now, this is a linear system with the variables x, y, z. So the variables that involved here, you can see that this is x, y, and also z. Okay, so it's represented in the form of ax equal to b as follows. So here you can see that Okay, so actually we will transform it. So this is an equation, a standard equation, but now we will represent it into a what we call a matrices form. So AX equal to B. So you can see here, this is a matrix A. Okay, actually whereas we get it from this one. We abstract from this. So matrix A means a matrix that contain only a coefficient. I mean only a number, coefficient for X, coefficient for Y, coefficient for Z. For example here, the first equation here, the coefficient for X here is 3. So we write here 3. The coefficient for Y here is 2. So we write here 2. This one is negative 4. Okay, make sure you consider the sign also, because this negative is belong to the coefficient lah, to the number. So it's negative 4. So the rest you just follow. So here is 2, we write here 2. Here is negative 4, so we write 4, negative 4, and here is 1. Okay, 1. So this is a matrix A. And then the matrix X here is a matrix that contains a variable. So X, Y, Z. So we write here X, Y, Z. And then equal to B. B is a matrix solution. Okay, the solution that we have here, we make it a matrix B. Okay, right? So this is a matrix A as B lah. Okay, right? So as we know, I mean the title for the topic is the solution of a linear system. Solution. So the keyword here is solution. So means that at the end you need to know, or you need to find out the value of the solution lah kan. So solution here means is a value that you should get for the variable X, Y, Z. So like this. Okay. So for this topic is you need to know, I mean you will learn how from this ASB we will get this answer. So from here, from this ASB to get this answer, they have a 3 methods. Okay, like I said before, you will cover or you will learn 3 methods, right? So so here this is the methods that I mentioned before. Okay, so this is the solution of linear system. Just now you already we call from the linear equation you make it become matrices. So this is a linear system. So you have 3 methods here. Okay, LU decomposition, Gauss-Seidel, and also Gauss elimination. So all these 3, they have a different approach. I mean they have a different step plus of course, a different step. So make sure you need to know. I mean when the question asks you to find solution blah 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 by using LU decomposition, make sure you do or you write the steps the correct one. I mean you use the correct method. For example, if the question asks you to use LU decomposition, but you answer by using Gauss elimination, even though the answer is correct, I mean you will get the same answer, you will get the same value for X, Y, Z, but it's not considered as work. I mean you will get nothing. You didn't get any marks because you not understand on the method. Okay, different method, different steps. Okay, make sure you understand it. Okay, maybe at this stage you need to memorize lah. Okay, I can say that you need to memorize the steps, right? Okay, so alright, so for the LU decomposition, okay, it is A equal to LU. So A is a matrix, it's a matrix just now that I said just now. Okay, matrix A that we get from the question A. Okay, LU, okay, L here represent lower triangular, and U is represent upper triangular. Later on I will explain or I will show you what's an LU. Okay, because we just go through first. Okay, so then how to get the answer? You will apply the forward backward substitution. Okay, it's not just these two, it's ada lagi lah. Okay, but at this, I mean what you need to know, this is how the basic things that you need to know for the LU decomposition. Alright, so the second one here is a Gauss-Seidel. So the mean here is you need to make it straight. You need to make it strictly diagonally dominant matrix. What is strictly diagonal nomenclature? Okay, later on I will explain. Because of, if you still remember, for the previous short question in the week 1, I asked you about diagonally dominant. Okay, so hope that you still remember lah what is that. Okay, alright. Okay, the last one is Gauss elimination. You will use a row reduction. Okay, alright. So I will explain one by one in the next video. Okay, but I will start with the Gauss elimination first, and then the second one is early decomposition, and the third one, the last one is Gauss-Seidel. Okay, I will explain in the next video. See you.